Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And in this video today we're going to take a look at converting and translating C++ code into x86 assembly language. I am working in a MASM environment with Visual Studio, and I'm also using the Irvine library from the textbook that we are using, Kip Irvine's book. I think it's on the 7th or 8th edition now. So we are using that library inside of MASM with Visual Studio to do our translation from C++ into x86 assembly. So let's take a look at the problem and get started. Okay, so here on the right you can see the C++ code we're going to be translating over into x86 assembly language. Here are my working environments. So I have a function called transformation. I'm going to be using 4 registers. There's no way to translate this directly. It has to make this a valid C++ program. I have to move some stuff around and make some, take some liberties here. So the EAX, EBX, ECX, EDX registers should already be set before this function gets called. And then I do some work, pretty simple, just some random arithmetic, and then I'll return a value from this function back over to here. And essentially what I'm doing is I'm looping this thing, however many times the user tells me they want to loop. They give me an input value, I transform it, and then I also do a couple extra things over here on this end just to kind of semi-randomize the results. And then on the other, and again, so like if I put 5 in, I get -10, but if I put 5 in later on, I won't get -10 a second time. I'll get some new value because all the other registers are also being manipulated as we move forward from iteration to iteration. Okay, so basically this is the output I'm expecting to see eventually, and I have a few more that we can test, but if this is working, we pretty much have everything working. And so again, my goal is to translate this from what you see over to here into something that we don't already have. Okay, so I'm going to do the main first, and then we can kind of work out the transformation one. So I'm just going to steal this guy here, and I'm going to put this in so I can see what I'm working off of, what I'm trying to do. And I know that before the exit here, I didn't copy this, but to call the wait message. And again, these are Irvine library calls that are in previous lectures on my end. So if you're coming in to watch this video outside of the class and the courses that I'm teaching, then these are just library calls that you could see in a previous video. I do have one that shows how all the Irvine library functions work. So anyway, this is the system pause, and now I'm ready to do kind of everything else before we get going. I do not need to worry about this. But I do need to understand, and you'll see this immediately, and this is probably where you'll see that my students will say that, this is where things start to kind of go wrong almost right off the bat, is that I am maintaining these 4 registers inside of main. So I have to make sure that the fidelity here and the accuracy of these values are kept through any line of code that I'm trying to perform that isn't saying that I should be modifying those registers. So just to say, that is something to keep in mind here. And again, you'll see here almost immediately where I want to move 2 into EAX. Okay, I want to copy that to 2. I'll put everything over here for comments. And then I want to do the same thing where I want to move EDX, or 1 into EDX. I don't know why, whatever, it's all good. Okay, so now it says replace. Oh, it's my name, so I don't have to replace anything, but I do need to print this thing out. And I know there's going to be 4 strings. So we'll get there. So I'll just call it A for right now, and that's a byte. There's my null terminating string. So what do I have? What do I want to do? I want to move into the EDX register the offset of A, so that I can call write string. And now let's just and then I can call CRLF. And let's just take a look at this. And I won't do we won't fix it up until later on, but you can see here in this line of code, and I just told you I'm trying to modify and maintain EDX. In the very next line of code here, I'm modifying it because I need to use this so that I can print the string to the screen. So I'm like, well, how will I store what was in there before and then come back to it later once I'm done using the register? Because everybody has to share this register. We're sharing it with the Irvine library, and so then the pushes and the pops are going to become very important. And so I'm going to put it in for the moment, and I'll come back to it later. I'm going to take it out after we're done. But when you're done with, when you want to use it for something else, I'm going to push, and then when I'm done with it, I'm going to pop it right back. So I can use it to do what I need to do, but then when it's all said and done, the workspace is replaced with what was there prior. And we do this in like 3 or 4 places, and then our code will magically work in the end here. So anyway, okay, so then, so that is a big thing of what we're going to do as we move forward here. So now I have this string, and then with this one, I'm going to move into the EDX register. So you can see again, I'm using EDX again, offset of B, so I can call write string. So oops, steal this guy, put him back. And again, I like to do this like this, where I have the code to the right that I'm trying to do, so I can at least see if things go wrong. I go, well, where did it go wrong? And now this is another one where I'm like, oh, I want to input into ECX, but the call for readInt modifies EAX, and EAX is up here, and that's one of the things we need to maintain. So I do not, just because I input something doesn't mean that I want to blow out what was already in the EAX register. And just to finish the deal here, I need to make sure whatever comes in gets moved to the correct register per what you see here. So EAX, whatever, you read into EAX, and then the EAX gets copied into ECX, and there will need to be a push and a pop for the EAX register when we get there. Okay, so continuing on here, I see a do-while loop, and whenever I see something like this where I'm decrementing ECX and then I'm testing against 0, well, that's just a loop instruction. And then I need a label. I like the loop again kind of thing. Oops. And that covers the do part. And then this part here is the actual loop. Excuse me. Loop again. And now everything else will be whatever it needs to be. So here's the next string we need to print. I can't use C as a keyword, so I can't use C, so I'll just use D here. And then, so I'm gonna, where is it here? So I'm gonna do move into EDX, and you see the pattern over there's another time I'm blowing out EDX. So there's my C out, and then, oh, I didn't do the call write string. And then this time I just need to do a readInt, call readInt, and I don't need to do anything more with it because as you see there, it already moves into EAX, the readInt, so I don't need to do anything more to worry about anything like that. So then now this is relatively simple. I'm going to move 19 into EBX. Oops. You get the gist here. I won't correct everything over here on the right because it's kind of inconsequential here in the moment. But then I'm going to add into EBX whatever EAX is. So that should handle that line of code inside the loop. And now with this, all I need to do is call transformation because these registers have already been set up by all the other functions. And again, the pushes and the pops will have to come in later, but I just want to I want to get the basics of everything going before I fill in the last steps. And also when this function returns, the EAX register will hold the return value. So I don't have to do anything more for this entire line of code, at least the way I have it set up here, than just call the transformation function. And I don't have that created yet. I'd like to have a little skeleton for it. So I need a ret here, and then I can come back here and I can do the NP. And so now I have something that will actually assemble and run when I have this thing working in a minute here, just to make sure I have at least the basic main loop going. Okay, here's the last thing the last string I need to worry about. I can use E. Okay. Same thing goes. We're going to come back to that later. So let's see, move into the EDX register, the offset of E, and then call write string. And then I'm going to be printing the EAX value, which is whatever's in there right now, which is the return value, so I don't have to do anything more than call write int. And then I can call CRLF. And then I can take this and I can move into the EDX register EAX. And then I can subtract off from the EDX register ECX. And then that pretty much covers the main loop. And again, is it working? Is it not? I mean, you can't necessarily test every part. We could do breakpoints and whatnot, but that's something maybe you can do on your own. And of course, remember, you can click on the gray area over here and set breakpoints for everything you're doing. So let me try running this and let's see what happens. Let's see if, in first case, did I even, I guess I wrote everything okay. So I go, well, here is what I have going. And well, how many times do I want to loop? I'll say 4. Oops, let me get rid of the breakpoint popped up, so whatever. So I'll run this, keep running. And I go, well, enter a value, 1. Whatever number I put in should come back out because we haven't updated the transform function. And this should loop 4 times. And it does. So I'm very happy with where this is right now. And so, and again, I'm not 100% happy because I believe I might be 100% happy, but I won't be until I check out everything else. So the next step now is to come in and fix up our function, our transform function, with this information here. And then when this is all said and done, then we can see where we're at, and then now we can worry about pushes and pops. So let's start that. Okay, so I'm going to use ESI to hold the temporary values for these things so we don't get confused. Cause like in this case, I'm setting ECX, but I'm using ECX here, so it can get complicated. Especially, like if I set ECX to 1 and then I added EDX to it, and then when I went to subtract it, I would not get the right answer. I would get 0 every time. So like I have to make sure that this is stored temporarily. This is like a temporary value, so that in the process of creating the new one, I don't return it just change it into something that it isn't supposed to be. So what I'm saying here is if I move 1 into ESI as my temporary storage zone, and then I add EDX to it, and then I subtract off ECX from it, and then I move that thing into the ECX, which is the final step. Now I think I've done everything I need because I moved 1 in, I added EDX, I subtracted ECX, and then I took the whole thing, the result, and moved that into ECX. And so I can do this a few more times over. In this case, I'm not using the same variable on both sides, so I could get away with just setting EAX to EBX, and then decrementing EAX, and then adding ECX to it and calling it a day there. So say set it to this, subtract 1, add this, and now the EAX register holds the result. And now for this one, same deal. So I can move into the EDX register ECX, and then I can negate it, because I need negative ECX, so I can negate EDX, then I can add EBX to it, and then I can add 2 to it, EDX, 2. And so just note that I negated EDX, even though I'm looking at ECX. Anything on the right-hand side of an equation is not going to be modified by the line of code. EDX is the only variable here listed in our line of code, and EAX here and ECX there. These are the only things that we're allowed to, or that are allowed to be changed in the line of code that we see. Because if we did manipulate these variables as we're doing this, well, that's not the programming I know, and I don't even know who would want to live in that world where we don't know, like it's line to line, that our variables are being manipulated. So only the one variable on the left-hand side is being manipulated here. And so just to finish up, this return is equivalent to saying like EAX equals this. Because again, the rule is when we return from a function, the EAX register is supposed to be the value, it's supposed to hold the return type. Okay, so what would I do here? I would negate EAX to start out on that, move this over. And then I would add ECX to it. and then I would subtract off edx from it. I got 15 minutes on my meeting, okay. And so, and then I can return, but now I can return back since everything theoretically is done. I'm not 100% sure it's done. We can try it out, that's for sure, and we can see where we're at. But I know if, in my heart of hearts, isn't going to work out. But let's try it. And now you'll also see by doing this that because remember a couple minutes ago that we were able to finish the program and it was able to end the loop. It's not going to do that anymore. So let's see. So if I put in 5 loops and I say -10, yeah, garbage, 11, garbage, -50, garbage, -99,999, garbage, 1770, garbage, and it's just going to keep on going pretty much forever. You might get lucky and get a 0 at the end of it, but no, there's no guarantee that ECX is going to be manipulated. So now, like I said, I think I have all the code written, and it's like, well, what's going on? And this is where the title of this lecture, of this discussion, is the pushes and the pops are going to mean everything. And we discussed this when we first started, that especially like for a function, I'm manipulating ESI, I'm manipulating ECX, I'm manipulating EDX in the process here. I can see the things. EAX doesn't matter because I'm supposed to be manipulating that. But everything else that, those 3 registers, at least in here, are being manipulated, and they shouldn't be, because again, I'm sharing them with main. And here on the main side, I'm manipulating them in ways I don't intend to either by using the Irvine library. So now the final steps are to go back in here and go through everything and check to see what do I need to push and what do I need to pop. And let's take a look at how we go about thinking that out and then solving the finality of this problem. Okay, so on the function side of things, what you could do is something like this, where you call dump regs right when the function starts and you call it right before it ends. And so what we can look at when we do something like this, and I'll put in the -10 values. I mean, it doesn't much matter what number I put in here. But you can see if I put in a 5 and then I say, oh, let's change -10 into something. And again, we're expecting it to come out with a -22, which isn't even close. You're like, why is that? That's because in main we're using pointer values instead of just value values, but we'll fix that. But you can see that, as I was mentioning, the EAX register should be manipulated. Because, and right or wrong, it doesn't necessarily matter right now, but the EAX register will hold the return value for what we're doing. And so now everything else, let's take a look. Well, EBX is the same, ECX is manipulated, and we know that because we can see that it was manipulated here, so we're going to have to push and pop that. Then same goes for EDX, because we can see that the values are different. ESI, the values are slightly different. Yeah, they are different. And then EDI, they're the same, EBP is the same, and ESP is the same, and everything else is not something that we can manipulate. So coming back, like, what did we learn from putting this in here? We need those 3 registers, ESI, ECX, and EDX, to have a push and a pop inside the function here. So I can get rid of this, and I can say, let's push ESI, let's push EDX, let's push ECX. And we know those are the only 3 because of the research we did. And then here on this end, before I return, I got to pop them back in the reverse order, because remember, a stack is a first in, first out data structure. So if this thing is sitting on the top of the stack, we want to make sure we put it back to where it's supposed to go. And then so the next one is to push, or to pop into EDX, and then this one is to pop into ESI. And I don't know if this necessarily will fix anything to do with the numbers on the screen, which you might look at that and go, well, how do I know I'm doing things right? But at least in your heart of hearts you're doing it right, because you've figured out which registers on that end need to be manipulated. And I don't know, again, if this is the same. I guess I don't know if this is the same values as before. It doesn't much matter again. But now we can go ahead and do this. Have the same idea over on the end of, or at least we can check to see if the loop ends after 5 iterations. So let's see. I'm just going to put 5th one, and then it ends. So yes, by doing what we did here, we did show that we manipulated ECX in a way that we pushed it onto the stack, and then we manipulated it, and then we put it back, so that when main got a hold of it, it was the value it was still trying to keep, like the loop counter. So the ECX register is working properly, and so I know that, at the very least, that these pushes and pops are working in the way I'm intending them to. So again, so now to finalize things, just in a few places here, down here, where the main is trying to maintain EAX, EBX, ECX, and EDX. And as we talked earlier, this thing is being manipulated. And so we want to keep this value. We don't care about this value. This is just to use so the Irvine library, gets what it needs to call the function. So once it writes the string, I can pop it back. And I can do that everywhere, basically everywhere I see a print statement. And we could work some efficiencies out, but if we just think of it this way, this is fine. And so I'm just saying, just doing this because I know there's 4 of them. I just got to remember, as I'm thinking, talking, doing, I just got to make sure I do push, pop, push, pop, push, pop, and then down here is one more. Okay, so that handles the EDX part of everything, and let's see if that fixes anything. At least, or maybe it'll fix everything. And the answer is no. There's still at least one more thing to do, but we're getting closer for sure this time. So 5, -10. It did crash. Exception thrown. So what did happen? I'm not 100% sure, but we'll take a look here in a second. So I mean, that's something, right? That's not necessarily great, but it's something to think about. But to say here, the EAX register is being manipulated here, and just like we said before, it's being manipulated, and then we're using it, but then we're trying to keep whatever that EAX value is. We're trying to keep that, as something different than when we used the function to get the job and then moved it over to ECX. So I do, in this case, think I should move into EAX. Push. I should do the push for the EAX. I do the job, and when I'm done, I pop it back. And let's see if that fixes the crash, and if it fixes maybe the whole program altogether. We don't know. Let's see. So now I put 5 in, I put -10. Oh, it crashes again. So I'm going to have to see what is wrong, and then we can fix that, and then from there, or let's see what's happening. Okay, so debugging, right? Debugging. And there's something wrong with my program. What is it? What did I do? Maybe you already saw it as I was doing it, and you're like, oh, whatever. Or maybe you didn't. But sometimes neither of us would know what we did, because maybe it's just something we didn't account for when we were writing our program. So let's see what happens if I put a breakpoint in here at the call transformation, and whoops, it already crashed. Let me just try this again. There we go. So how many times do I want to loop? 5, -10 to start. So I hit this breakpoint where I call the function. So right now it hasn't crashed yet, but if I hit F11 to go in, and you can see, okay, I push, I push, I push. I'm doing work, I'm doing work, I'm doing work, I'm doing work. So far, so good. I return back. I push this value on the stack. So the transformation function isn't where things went wrong either. And then I move this offset, I pop EDX, and I call write string, and there it is. Like, what? Like, what is happening? Why am I crashing? And now you have to think out, what is it that I did? And it just happened to be, again, while I'm thinking and talking and doing all at the same time, is that I need to put the pop EDX after I've used it. So I had the right thing in the wrong place. And so like I'm using EDX to call the right string, and then I can put the value back to whatever it is I want it to be. And now let's see if I did it right. And now let's see if it fixes the crash, which it should. So let's say I put a 5 in, I put a -10 in, and -22 comes out. I put 11 in, -91 comes out. I put in -50, -36 comes out, -999. I get my 1919. 54, and I get 1770. My program ends. Everybody's happy. And let's just try the other ones just to kind of make sure here. So I got 3 loops. I start with 10. I get my -60. My 99 then comes in, and then my 11 comes in, and there we go there. And so it looks like everything's working. So again, the main goal here is, the pushes and pops can save everything, and they need to save everything, because as you're working through this, as you're doing all this, we have to maintain that the registers have to keep values from all of the other processes we're trying to accomplish at the same time. Not saying it's right, and not saying it's fair, but it's just what we've been afforded by the architecture and all the engineers that have been working on this processor for all these decades. So, and again, you saw that without these pushes and pops, it's hard to know if you have things working right, or it's hard to know, you know it's not working, but you don't necessarily know what it is. But if you kind of work through everything and just kind of see, almost on a line-by-line basis, am I manipulating the things that I want to manipulate? And if I'm not manipulating them, I'm manipulating something that I want to keep. Well, how would I go about saving that for another time? Like, how would I, save that value so when I'm done, I'm done. And so, yep, everything is working here. My code matches up with what you see here. Let me see how small I can get it. So I can put everything on one thing there. Almost. There we go. There's the whole program. Who knows if you can see that? I know it probably gets very blurry. But just to say, here's my transformation function that matches up with what you see there. And then with this, it's a lot of lines of code for 4 lines of code, right? And then here on this end, the main function, you can see that's what does everything here. So as always, if you have any questions, you can email me directly, swardb@cod.edu or bradleysward@gmail.com. Comment below. Do all the things you need to do. And if you know any ways to make this better, of course I'd like to hear it, as long as it's respectful. It's nice to hear from you guys out in the world who watch these videos and glean something from it. So thanks for sticking it out with me as always. I hope you guys have a great time. Spring is starting here in the year 2024, at least right when I'm making this right now. And well, hope you're having a great week. Hope you're having a great day. And we'll see you in future videos. Thanks, everybody. Take care.